Good morning, students. Our today's topic in the subject of physics class O level is static electricity. And today we are going to read the first lecture of static electricity. So this is a technical topic. So concentrate yourself. A lot of concentration is required. So we are going to start now. The flow of the electrons along the conducting wires in a circuit produces an electric current. In an electric circuit setup, the electrons always flow from negatively charged end to the positively charged end of a cell or power supply. So this is very important point to remember. In an electric circuit setup, the electrons always flow from negatively charged end to positively charged end of a cell or power supply, thus supplying electric energy to components such as a lamp. Whereas the direction of the conventional current is opposite. The direction of the conventional current is taken to be the direction of the flow of the positive charges. The direction of the electron flow is opposite to that of the conventional current. So this is very important point to remember. The direction of the electron flow is opposite to that of the conventional current. So if electrons flow from negatively charged end to positively charged end, then conventional current flow from positively charged end to negatively charged end. So this is very important point to remember. Here is a figure. So you can see the flow of the electron is from negatively charged end to positively charged end, whereas the conventional current is from positively charged end to negatively charged end. So this is circuit symbol, this is cell, and this is lamp. Here is a question. The lowest part of the cloud has a positive charge. So you can see here, the cloud discharges in a flash of the lightning. In which direction do electrons and conventional current flows? So conventional current flows from positively charged end to negatively charged end. It means conventional current will be downward. So downward, A option or C option will be there. So we will discard B and D. And electron flow is from negatively charged end to positively charged end. So it means the electron flow will be upward. So this option C is a right option. Electron flow upward from negatively charged end to positively charged end, whereas the conventional current is from positively to negatively charged end. So C option is the right answer. So here is the explanation of the answer. You can see C. The lightning is conducting path for the cloud to gain electrons since it has a positive charge. Conventional current is just the opposite direction to the electron flow. The flow of the electrons occurs only when there are charged objects. Likewise, the lower end of the cloud was charged and the building top was charged. So that's why the flow of the electrons was conducted. An object with a negative charge gives out electrons, with a positive charge receives electrons. So cloud's lower part will receive the electrons and the building's negative charge will give the electrons. There is an electric current only when there are moving electric charges. The more the charges flow through the circuit in 1 second, the bigger is the current. So this is quite common sense. The more the charges flow through the circuit in 1 second, the bigger is the current. Here is the definition of the current is coming. Current is the rate of flow of charge. Equation is I is equal to Q over T, where I is the current, Q is the charge, and T is the time. So when we use this equation, charge will be in coulombs, current will be in amperes, and time will be in seconds. The instrument used to measure electric current is ammeter and must be connected in series in this circuit. So this is another point to be remembered. The ammeter must be connected in series in this circuit. The SI unit for the current is ampere. An ideal ammeter must have a very much lower resistance compared to that of the load, so that the amount of the electric energy dissipated is very small. So this is very important thing for the ammeter to be used. Its resistance must be very low as compared to that of the load. In this manner, the current I flowing in the circuit will not be smaller than what it should be. Here is an exam tip for you people. An ammeter should be connected in series. Electric current should flow into the positive red terminal and out of the negative black terminal of the ammeter. So look now, flow into the positive red terminal. Here is the red terminal, and out of the negative black terminal. Here is an exam tip for you people. Therefore, if the reading of the current is 1 ampere, as it was shown in the ammeter, so this was reading 1 ampere. If the reading of the current is 1 ampere, it means one coulomb of the charge passes a point in the circuit in 1 second. If the current reading is 2 ampere, there is 2 coulomb of charge per second, and so on. Do you know that although current takes very little time to travel from one point to another, the electrons in the wire of the circuits travel at very slow speed. The ability of the cell to drive a current is measured by its voltage. So this is very important point. Concentrate yourself. The ability of the cell to drive a current is measured by its voltage. This is indicated by a figure on the side of the cell with the letter V after it. So you have seen, for example, this is written 3 volt, this is written 6 volt, this is written 9 volt. The volt symbol V is the unit used to measure the difference in electrostatic potential energy, usually just referred to as potential between the 2 points. The voltage written on the side of the cell refers to the difference in potential between its positive and negative terminals. So this is the difference in potential between the positive and negative terminals of the cell. It is a measure of the electrical energy that the cell can give to the electrons in a circuit. Here is some practical work. Measuring current. Connect the circuit of the figure on a circuit board if possible, ensuring that the positive of the cell, the metal stud, goes to positive of the ammeter. So look now, positive of the cell is connected to positive of the ammeter. Note the current. Connect the circuit of the figure. The cells are in series. So here you can see the cells are in series. Positive of one to negative of the other, as are the lamps. Record the current. Measure the current at B, C, and D by disconnecting the circuit at each point in turn and inserting the ammeter, what do you find? So look here, you will find that the current is the same at all points in the series circuit. Next, connect the circuit of the figure. The lamps are in parallel now. So here are the lamps in parallel. Read the ammeter. Also measure the currents at P, Q and R. Here is P, here is Q and here is R. What is your conclusion? So look now, the conclusion will be the sum of the currents in the branches of the parallel circuit. So here the whatever the sum will be equal to the current entering or leaving the parallel circuit will be equal at this point and this point. So entering and leaving the current will be equal to the sum of the currents in the branches of the parallel circuits. So this is the difference in series and parallel. In parallel currents, equal amount of the current will flow in all the lamps, whereas in parallel circuit, the sum of the branches of the current, sum of the current of, in the branches will be equal to entering or leaving the current. Here is a question. If the lamps are all in the same in the figure below, and if A1 reads 0.50, so this is the reading in this ammeter, 0.50 ampere. What do A2, A3, A4 and A5 reads? So look now, these are in parallel. So everyone, A2, A3, A4, A5 will read 0.25 because sum of the currents in the branches will be equal to current here. So if there is 0.50, so 0.25 will move into this branch and into this branch also. And then these are in series, so 0.25 will move from here and 0.25 will move here also. 0.25 will move here and 0.25 will move here also. Here is another question. A milliammeter shows a reading of 30 milliampere. How much electrical charge flows through the milliammeter in 10 seconds? So whenever you solve the questions, remember time should be in seconds and current should be in amperes. So these are the standard units. So we have to convert this milliampere into ampere. Time is already in second. Okay, so look now. 1 ampere is equal to 10 raised to power minus 3 ampere. So that's why 30 multiplied by 10 raised to power minus 3 will be equal to amperes now. So I is equal to Q over T equation is used. So Q is the requirement. So T will be multiplied by I. So Q is equal to IT. I is 30 multiplied by 10 raised to power minus 3. And time is 10 seconds. So multiply it on the calculator. Answer will be 0.3 and column will be the unit. Here is an exam tip for you students. Current is in ampere. Must remember to convert to this unit. This is very important. And 1 milliampere is equal to 10 raised to power minus 3 amperes. Here is another question. If 30 coulomb of the electrical charge flows past a point in the wire in 2 minutes, what is the current in the wire? So 30 coulomb is okay, but time is given in 2 minutes. So we have to convert this 2 minutes into seconds. So I is equal to Q over T is the equation. Q is 30 coulomb and time is in 2 minutes. So in 1 minute there are 60 seconds. So 2 multiplied by 60. So solve it on the calculator. Answer will be in ampere. Here is another question. The current in a lamp is 0.2 ampere if the lamp is switched on for 2 hours. What is the total electrical charge passing through the lamp? So look now, 2 hours are given. So we have to convert it into seconds. So in 1 hour, there are 60 minutes, and in 1 minute, there are 60 seconds. So I is equal to Q over T is the equation used, and Q is the requirement. So that will be equal to IT. Current is given 0.2 ampere, and time is 2 hours. So 2 multiplied by 60 multiplied by 60. Now the time is in seconds. Now solve it on the calculator. You will get the answer. Unit will be coulombs. Here is another question. Two batteries, each of EMF, electromotive force 3 volt, and internal resistance 4 ohm are joined. So look now, internal resistance is 4 ohm and EMF is 3 volt, are joined in series in figure A. So these are joined in series, and then second in parallel. So in parallel in figure B. Calculate the current through each cell if a wire of 2 ohm is joined. So look now, a wire of 2 ohm is joined to each arrangement. So in the first part, when series, total EMF will be 3 plus 3. So because this is in series, so 3 plus 3, 6 volt. And total internal resistance will be 4 plus 4 ohm. That is 8 ohm. But a wire of resistance 2 ohm is also joined. So I is equal to 6 over 8 plus 2. Solve it on the calculator. So this will be the current. Whereas in parallel, EMF will be 3 volt for both of these cells. Whereas the resistance will be 1 over R is equal to 1 by 4 plus 1 by 4. That will be equal to 1 by 2. And take the reciprocal of this one. So R will be equal to 2. And a wire of resistance 2 ohm is also joined. So 3 over 2 plus 2. Solve it on the calculator. That will be the answer. So this was the lecture, students. This was the first lecture of the current electricity, a very important one. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.